Hi everyone, welcome to the video on measures of center and spread. In this video I'm going to go over how to find all of those measures for continuous probability distributions, and we'll just work through this example and see how it's done for sort of everything. Now when I'm talking about measures of center and spread, or measures of central tendency and measures of spread, what I'm talking about are mean, median, mode for the measures of center, and then range, interquartile range, standard deviation, and variance for the measures of spread. So let's start off with, well, we've got this probability distribution here, f of x equals 4x cubed between 0 and 1, and then 0 otherwise. So what I'm actually going to do to start off with is I'm going to sketch this, just a very rough sketch, just so we have an idea of what it is that we're actually looking at. So, oh, that's alright. So, this graph that's going to pass through the origin has a closed circle there, and it's x cubed, so it would normally come up here and then continue upwards after going through the point of inflection. So this is just going to go like this, a little bit steeper than normal, and I don't really know how steep it's going to be, but you know, that's just roughly what we're looking at between x equals 0 and x equals 1. So that's what we are looking at here. And there's 0 otherwise, so well, it's just going to be flat along the x-axis for the rest of it. Now, what we learned back in anti-differentiation was that we could find the area under a curve, and that's basically what we're going to do here. If we want to do the expected value, I'm going to start off with that one because, well, it's just a nice one to start off with. So I'll just write this down. To do the expected value, now in discrete distributions we use e of x, but because we're dealing with continuous distributions, now I'm going to use mu, and that's equal to the integral between negative infinity and infinity of x f of x dx. So you might be wondering, what's the reason for this x multiplied by f of x, and what do we do about the negative infinity and positive infinity? You can get the negative infinity and positive infinity from your calculator. I'll just bring it up here. You can see I've been able to play around with some numbers, but in Math 2, you've got the infinity button right there, and that one can be used in calculations, but let's not worry about that. So in this case, we don't really need to worry about negative infinity to positive infinity, because this graph only really exists for 0 to 1. So that's what I'm going to do here, and I'll just write that down. So we've got the integral between 0 and 1 of x times f of x, which in this case is 4x cubed, dx. Okay, so again, coming back to what does x times f of x do? Well, that's actually just what we've been doing for all of the expected values. We did the x value multiplied by the probability of the function. So, you know, if we take this x value here, for example, well, the probability of it is going to be measured there, and by taking the width of that, you know, measuring it as an infinitely narrow rectangle, we can figure out what that probability is. Now, going back then further to our anti-differentiation, what we're going to do is we're going to take the sum of all of those. So we're taking all these rectangles all together, and it's going to tell us the area under the curve there, which, well, happens to be the expected value in some regard. So what I'm going to do next is I'm just going to evaluate this. So that's the integral between 0 and 1 of x, sorry, I should say 4x to the 4 dx, which becomes 4x to the 5 on 5 plus c, but we don't need to do that because it's a definite integral between 0 and 1. And when we sub those in, well, the 0 doesn't really affect it in any way, but the 1 will just make it 4/5. Technically minus 0, but that's going to be the answer to that particular problem. So that's the expected value, and we don't have enough time for any more in this video, but we will come back with more in the next one. See you then.